A z-score makes it possible to compare scores from different distributions. The values are interpreted in terms of the number of standard deviations their position is above or below the mean. A positive z-score indicates the value is above the mean. A negative z-score indicates the value is below the mean. The formula for calculating z-scores is identical when working with a sample or a population. The z-score equals the value when the difference between the data value and the mean is divided by the standard deviation. A minor difference when calculating a sample z-score is using x-bar and s for the mean and standard deviation, while the population z-score uses mu and sigma. Let's look at a sample problem using z-scores. Tom and Jerry each have a standard score on an intelligence test, but they are on different tests. Tom received a standard score on the Stanford-Binet Intelligence Scale of 116. Jerry got a standard score of 121 on the Wechsler Intelligence Scale, WICS, 4th edition. Who scored better? The Stanford-Binet has a mean of 89 with a standard deviation of 16. The Wechsler Intelligence Scale has a mean of 100 with a standard deviation of 15. Since these scores are from different distributions, then we must use z-scores for the comparison. Tom's standard score is 116. The mean of the test is 89 with a standard deviation of 16. Since we are working with a population, the equation will use mu and sigma for the variables. Substitute 116, 89, and 16 into the equation. The result is approximately 1.7. Jerry's standard score is 121. The mean of the test is 100 with a standard deviation of 15. We will use the same equation as with Tom's. Substitute the values 121, 100, and 15 into the equation, and we will get a result of 1.4. Now compare the scores. 1.7 is greater than 1.4. So we can conclude Tom scored better.